Now, next on the agenda is Dr. Eduardo Grimaldo from Sintef. He was going to talk about selection in mid-water trawl fisheries for cod. However, yesterday he had an emergency and he couldn't make it. Then he called up Haraldur Einarsson, his good friend, and he's going to take care of the presentation on his behalf.
Good morning. Well, I'm going to present this. I don't know nothing about it, so I will try to go through it. But anyway, I know something about selectivity, so we try to go through this together. Please don't ask difficult questions. So let me see. This is where do we go on with this? Is it just this one? Yeah. Okay. Here's the background. He is working with mid-water trawling, and he is planning to try, saying that he's reducing the impact on the seabeds and associated the fauna. And that is truly. The mid-water trawl require less energy than bottom trawling, with the consequence reduction in fuel cost and NOx emissions. It opens the possibility of trawlers to combine bottom and pelagic trawls. So here he have done a bit measurements, and he done energy consumption comparisons. We, that would be they in this case, compared energy consumption in kilowatts for trawling with 3 trawls setups, each and in and out of fjords at the same depth and towing speed. So there are 3 offsets here. They have the bottom trawl. We have a red light on this here. Yeah. They have this bottom trawl here with a bottom trawl doors, 9 square meter. Then they have the same bottom trawl with a semi-pelagic or pelagic bottom pelagic doors, which are 6.5 square meters. And then finally, mid-water trawl with 6.5 square meters pelagic trawl doors. So in a way, they have the same trawl here, different doors, same doors, different trawls. So with changing from bottom trawl to semi-pelagic trawl was 17% reduction. But from the bottom trawl to the mid-water trawl is minus 5%. Well, with reduction. So actually not, maybe reduction. But it's a good explaining for that. The size of the trawl is quite a lot bigger. It's 40 times bigger. So of course it have more tension against it. Okay, that was this slide. So here we have the challenges regarding the selectivity. Size selectivity at extreme high catch rates. That is a case they had now in Norway for about 2 years. It have happened sometimes here in Iceland as well, and I'm sure in other countries. It's a bit crazy situation. In the area in Norway, it's mandatory to use sorting grids, originally designed for bottom trawling, and have a capacity problems when fishing with pelagic trawls at extremely high catch rates. So, to control of the catch size, the risk of taking excessively big catches can potentially lead to reduced quality of the catch and also be associated with handling problems and other HSE related problems. So, in some many years ago, 54 tons taken by 8 minutes tow would be told as a lucky catch. But when we are dealing with quality, and like that, it is really bad cuts. It's difficult to go through this. So this is not good situation. Something people don't want to have on board. Not like this. Selectivity experiments. They have this objectives and development of selection system based on flexible web panels, exit windows, or T19, which has significantly greater capacity than the current sorting grid system. The selection system were a quadrant with 130 mm lateral exit window panels, a 135 mm T19 quadrant. You all know what T19 is. It's just a net turned 90 degrees. It's the same net as we use. A 55 mm sorting grid sort V type. That is the type of the sorting grid they are all using. Used here in Iceland as well and other countries. They had done 6 cruises and 112 holes with selectivity data. And here's the list of it. And tested 55 mm grid, 130 mm exit window, 135 mm T19 quadrant. Seems to have a very good data. Results. Exit window and T19 showed good and stable selection even with very high catch rates. And you can see this table here. Here's the main numbers, important numbers, L50 in the cod, 54.0. With selection range 7.8. 54 is quite high. And even here, when they use a quadrant with the exit window, they're getting L50 in 56.2. This is quite high as well, with a bit higher selection range. A bit amazing numbers, I would say, from my point of view. This is important as well, the variation between the trials in L50. Here is jumping up and down on 14, so it's not as stable as the exit window with only 7.1. Exit window on T19 quadrant catches less than 2% of undersized fish in areas with 16% undersized fish. Quite good. But Norwegian Directorate of Fisheries say not accepted as a technical measure for size selectivity in trawls. I don't know what is going on here. Probably some conflicts. I'm not sure. Eduardo would know that better than me. Problems with the sorting grid. These problems look for me very familiar. It's the same problems here in Iceland. It's a saturation of the grid in the front of the grid. The collection of, when there's a big catch in short time, we are getting up to 50 tons in few seconds or few minutes. The grid cannot let it all go through. Fish does not fall back to the content. Probably reason is the flow of the sea water go out of the grid system, and there is no flow of the water here, so it's quiet sea. The fish is not falling back. Catch sensors fail to give right information of the catch size. That is one of the things people are mostly complaining about here in Iceland and I know in Norway as well. But the Norwegian Directorate of Fisheries say sorting grids are and will be the technical measure for the size selectivity in trawls. Okay. Further development of the grid sections seems to be the way, as this is the response. They assessed the water flow of sorting grid section in the flume tank in Hirsals in Denmark now in June 2013, and was measuring of the water flow in full scale. So they just put the part of the grid system in full scale into the tank. So here's the results. This is a 2-panel sorting grids with 2 net panels in both ways. That is the normal way to use it. And with a lifting panel in the front, and they've found out that it's blocking all the section. So the water flow is not going well here through this system. Blue lines indicate the water flow speed reduction. 1 square is equivalent to 0.95 meters on second. So they have another, that is a 4-panel sorting grids, just like a sorting V, without lifting panel in the front. So now we have a 4-panel instead of 2. So they make the panels like a box. So they have 1 panel up and down and on the sides. Okay, and no lifting net here in the front. A 4-panel single grid section without lifting panel has a larger cross-section area, better stability, and better water flow. 4-panel sorting grid, or sort V, without lifting panel. Full-scale experiments with this type of grid section are planned to be performed in October 2013 in board of Ramoen. And he say, thank you for your attention.
You say that too.
Yeah. So, if there are any questions, I try to answer.
I didn't catch what sea were you fishing with those results you have showed us?
This would be in Barents Sea, I think, and from Lofoten and north of that, isn't it? Yeah, that is the area. And that is the area they have this problem today. It's a crazy problem, too much cuts.
Was it, and it was caught?
Yeah, caught, yeah. Any other? Good.